So question 26 is also from section 9.3, and we're still using the t-test, but this is asking slightly different questions. So you're going to need to be able to recognize the different ways that the questions from 9.3 can get asked, and make sure you're using the right sequence for each one. This one, it's giving you data, so you know you're going to end up needing to enter that into L1, and then it gives you a dot plot. So then it asks you some questions about the dot plot. Is it reasonable to assume the conditions for performing a hypothesis test are satisfied? Explain. So first question asks if there are any outliers. You just need to look at this visually, but here's what I'm going to tell you. If it says part 1 of 6, then you're probably going to answer no to these two first questions, because if you don't, then there's no more parts to the question. And just the way I've seen it set up, the ones where you would answer no to either of these, it's just part 1 of 1. So if you can see that there's other follow-on parts to the question, then chances are you're going to say yes to, or rather no to both of these. So no outliers. This dot out here, you could maybe argue is an outlier, and they're not really giving you any way to calculate whether it's an outlier. You're just supposed to do it visually. But knowing what we know about it being part 1 of 6, say no to the outliers. Evidence of strong skewness. Skewness means it's like a bunch of the data points are bunched out over here, and then they're more separated over here. And in this one, I don't really see any strong evidence of that, so say no to that as well. As long as you've said no to both of these, then you say we can assume that it's approximately normal, and it is reasonable to assume the conditions are satisfied. So chances are, if you see this one, it's going to be no, no, can, is for these 4 answers. And then you go on to do the actual problem. The null and alternate hypotheses, that you're going to do just like you've done for all of chapter 9. So the consumer organization reports that the price is greater than 310. Do the data provide convincing evidence of this claim? So the claim is that they're greater than 310. So your H0 is going to be mu equals 310. H1 is going to be mu is greater than 310. And then we go right into the test statistic. It's a t-test, and we know that for sure because it's asking for a t here rather than a z. So I've already entered the numbers into L1, but you need to do that first. And then stat tests, t-test, change your input from stats to data. The mean is the number we're comparing to from H0, so that's 310. The list is L1, frequency is always going to be 1, and in this case it was greater than 310 was the direction we had for H1. And calculate. So T is 1.946 3 decimal places, so 1.947. And then it wants the correct interval for the p-value. I don't think you ever had this as a homework question. There may have been something like this on one of the quizzes and it hadn't been on a homework, so you probably still have no idea how to do this. And it's kind of a pain, but you need to use that 1.9466. So I'm going to try and write that down over here just to have it for reference. 1.947. That's what I got for my t. Because now we need to go to the table. And again, you'll be able to get to that table from the link up at the top here, critical values for the students t-distribution table. But if you would rather use it on paper, then make sure you've got a printed copy of table A3 around. So first, sample size -1 to get your degrees of freedom. And the sample size is 10. 10 refrigerators here. So our degrees of freedom is going to be 9. So this is the row that we're going to be looking at. And then we're going to try to find a number, the numbers that are just above and just below our t-value here. So 1.947, but we have to find it in this row. So 1.9 is bigger than 1.8 but smaller than 2.2. So then we followed these rows up. You did have some problems in a homework that were similar to this, but it wasn't exactly like this. They just gave you the t and then you had to go through all these steps and it looked different. Okay, so we found where the t-value would fall in between these two numbers. And then area in right tail are the numbers up here, the 0.05 and the 0.025. And then we have to look back at our H1, and if it was a not equal, then we're going to double these two values. In this case, it was greater than, so we're just going to leave these two numbers alone. And then we reverse the order of the two values. So it's 0.025 and then 0.05, and that matches right here. And I'm going to highlight that because we're going to be using, ooh, I thought I was going to highlight that. There we go. Because we're going to be using this for part 5. So, so just to review that real quick, we found our row by taking our sample size -1. That gave us 9. Then we looked at for our t-value of 1.947 and where that would fall in this row, and it would fall in between these two numbers. Then we followed these two numbers up to the heading, and since it's a greater than or less than, we leave the numbers alone. If it had been a not equal, we would double them, and then we reverse the order. So we've got 0.025, 0.05, and that matches this answer choice here. So then determine whether to reject H0. So we know that when we get the p-value from the calculator, then we can compare that. And actually, since we did this in the calculator, we've got the p-value here, the actual number, and it's 0.043. And all this is telling us is, it's kind of, if you didn't have the calculator, you weren't using that, and you had to get the p-value from the table, you wouldn't know the exact p-value, but you would know that it fell in between these two. So come to think of it, that's a good way to double check your answer here, is to come back and say, does the p-value I got on the calculator match this? And it does, because this means it's in between these two values, and it is in between those two values. And as long as that all worked out, you can just compare the p-value you got in the calculator to the alpha value that you got, or that you were given here. In this case, the p is lower than alpha, so you reject here. And then your conclusion would then be that there is enough evidence to conclude the mean price is greater than 310.